video K7 to help me with reading and making line plots. So we're going to start out by making some. If I notice, I got a title up here, weight of mini pumpkins. I have an x-axis that's labeled in pounds. Here are my mini pumpkins. This is my data. And you'll notice there are halves in these, so I need to come over and make sure that I have labeled these with halves in there. If you don't realize what comes in between, just think, hey, what's between a size 6 and a size 7 shoe? Well, the only one that I know of is a 6.5. So now that we have the halves ready, when you make a line plot, they can either use X's or dots. X's are probably easier to see. So I just go down my list. I got a 3.5. I put an X above the 3.5. It's sort of like you're building a bar graph. I got a 3 and a 4.5. So there's the 3, there's a 4.5. I'm trying to get 2 at a time. 3.5 and a 5. 3.5 and a 4.5. A 5.5 and a 5. And a 3 and a 3.5. So we've got them all plotted. And now that's why I say it sort of looks like a bar graph, because you can tell that 3.5 pounds was the weight of most of the mini pumpkins. The largest mini pumpkin is not a 7 because there's no X's there. It's way back here where the X is because this is the mini pumpkin. It's 5.5. The lightest mini pumpkin would have been a 3. So the difference between the largest and the smallest mini pumpkin would have been a 5.5 minus 3, which would just get us to 2.5. Remember, difference is the answer I get when I subtract. Checking this one out. So we got lengths of frog tongues. What fun to measure. And we're labeled in inches. I come check my data. We got some in halves. We got some in fourths. And we got some in 3/4. So between 0 and 1 is going to be 1/2. Exactly in the middle between 0 and 1/2, think money. So if this is $1/2, which is usually 2/4, if I only have half of it, that would be 1/4. And another way to say 1/4 is 1/4. What's between 50 cents and $1? Well, that's 75 cents, which is the same as 3/4. Over here, we're going to have the same thing, except we're going to have a 1 in the middle. I like to do the one in the middle first because I think it's easier to split things in two and visualize where they're going to be just by cutting them in two instead of starting with the 4th. I'm talking about 4th and almost wrote it. Going back through, putting my X's in, I got a 1 and a 4th, 1 and 1/4, 1 and 1/2. I'm not sure what's going on here, but it looks like this is 3.5. That can't possibly be. We're just going to get rid of this data for a second. 3/4. Sometimes when people write down data, you can't remember what they're doing. I have a 1 and a 1.5 and a 1 1/4 and then just a plain old 1/2. Okay, again, if I ask you like what's the biggest one, well, there are no X's above 2, so it's going to be one of these two guys right there. So 1.5 inches long is the longest tongue. The shortest tongue is not a 4th. It's not 0 because there are no X's there. So that must be it. Try another one out. And when I look at this one, I go, oh my goodness. Because I look over here and I can see 1/8 inches. So the harder part of doing the line plot is getting your x-axis down here with the right numbers on it. So right in the middle of 5 and 6, I know this is going to be 5.5. And I know right between 5 and 5.5, it's going to be my 5 and 1/4. And right here is going to be 5 and 3/4. But if I look over here, I notice I'm going to have a 5 and 7/8. So we're going all the way to 1/8 inches, just like when we were measuring with 1/8 inch rulers. So this is 5 and 1/8. This would be 5 and 2/8, which really means the same as 5 and 1/4. Here's my 5 and 3/8. 5 and 4/8 is the same as 5.5. 5 5/8, 5 6/8, same as 5 3/4, 5 7/8. And then I'm going to do the same thing over here between 6 and 7. So I got 6 1/2, split it in two, I got 6 1/4, split this one in two, I got 6 3/4, split here, there's 6 1/8, split here, 6 3/8, split here, 6 5/8, split here, 6 7/8. And I just start putting my x's where they go. I got a 6 1/8, 5 1/2, 6 3/8, 5 3/4, 5 1/2, 6 1/8, 5 7/8, 5 1/2, 6, and 5 1/2. So if I'm just looking at my bars graph kind of part of the line plot, most of the roses were 5 1/2 inches. In fact, there were 1, 2, 3, 4 of them. That was also the shortest rose, and the tallest rose would have been 6 3/8. Remember, all of these guys out here look like they could be taller, but there are no X's for the roses. What if I wanted to know how many roses they measured? Just count the X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nothing to it.